Okay, so let's run that equation, which will give us the final size of S. And remember what we talked about, the bigger the size of S at the end of the epidemic, the better, because it means fewer people were infected in the long run. And then remember that this coefficient of natural log of S over 999, this was made of those parameters: the recovery rate 0.07, the death rate 0.002, and then we're going to focus a little bit on the terms that make up the infection rate lambda. So remember, this fraction here is denotes the fraction of the people met per unit of time. We said like 10 out of 1,000 as a first example. And again, remember, these are not official numbers, okay? These are just basically examples. And then let's say 0.1 will be the probability of meaningful contact, meaning getting close enough to the infected person, and then 0.1 and the probability of the infection to be transmitted. Let's say an event happens that makes the virus to be transmitted, like a cough or sneeze and so on. So with these parameters, if we run the equation, the solution is less than 500, which means that more than 500 people will be infected. I should say here that this is another solution which doesn't have any, so this is not a feasible solution, so we're going to ignore any solution of the equation which is above 1,000, because that's not biologically feasible. So the way we run the model, remember, the assumption is that the population is 1,000 to begin with, so the only biologically feasible solution for the final size of S is a number less than 1,000. So this outcome, of course, is bad, right? I mean, it means that more than half the population will be infected, right? Because if S is 496, it means that the rest of them up to 1,000, which is 504, are either recovered or dead, but that means we have more than 50% of infected cases. So let's focus on what happens if we, like I said, if we wear the mask or put some cover on the face. Okay, so let's imagine that the effect at the population level of most people doing this, making this habit of covering the face, especially in crowded places, let's say it will result in a modest modification of this probability. Let's say the effect is equivalent to increasing the average distance between people. So let's say between 0.1, the probability of meaningful contact will be 0.09. So even if we make a pessimistic prediction that the effect is very small, in the probability, if the effect is very small, at the population level, it's not that small. So notice that the final size of S now is 625, which means now we have only 375 people infected, and that's 125 fewer infections if we make that modification. So that's 125 cases in 1,000 people. That's a big percentage. Whether it's really big or not, that's a subjective assessment, but for sure it's a meaningful effect at the population level, although individually that may not be much of a difference. But again, let's go back to the main idea. For the infected person, especially in this case with the COVID, right, that apparently can be transmitted while people are asymptomatic, so people without symptoms, obviously if something is put over the face, any cough or sneeze is contained to an extent, to a big extent. But even in the case of healthy people, there is a non-zero reduction of the probability. Of course, small particles are not stopped by a scarf or a simple surgical mask, but maybe you are unlucky to be right at the wrong moment when someone basically coughed or sneezed, and then you just happen to be in the next second in the same area, and then there are big droplets, whatever, in the air. So the scarf or whatever you put on the face may still reduce the probability of at least larger particle to come in. So either way, it's a non-zero reduction of probability, and however small, it can have a big effect or a significant effect in the long run. Again, especially in the crowded places, because even when you have one fewer infection in a given day, because that person who was otherwise infected could have transmitted the infection further to 2 people or 3, and then each of them would have transmitted the infection further to 2 or 3 more people, and so on and so forth. So one should not neglect the effect of reducing the number of cases in a given day by a small amount, especially if you are in that period when the number of infected cases increases exponentially. Now, it's true that the same effect or a similar effect can be achieved if you modify the behavior, for example, right? So let's say the social distances works to an extent. So instead of having this, 10 out of 1,000 people met in a given day, you have 9 out of 1,000 in a given day. So you have a similar effect, obviously. I put here 0.09, yeah. So it was 0.01, so let's make it smaller, 0.009. So a similar effect, fewer infections so you have more than or less than 50% of people infected if you didn't have that social distancing. And of course, if social distancing works even better, let's say instead of 10 people out of 1,000, now you have only 8 people out of 1,000 as a fraction of people that you meet in a given day, you have an even bigger reduction, right? So now you have only 200 infections, right? Because the final size of S will be 800 or close to 800. But nothing stops people to actually implement multiple methods. So, the point I'm trying to make with covering the face still stands. Because let's say social distances reduces this probability from 0.01 to 0.008, but again, let's reduce also slightly the probability of meaningful contact because of that habit of covering the face in crowded places. So together, these reductions of the probabilities, of course, have a much more dramatic effect. So now we have basically pretty much a success story, right? A final size of 955 for S out of 1,000 would mean just 45 people infected out of 1,000. So this is, of course, a toy model, textbook example or a problem if you want, but I think the point still stands that the lack of strong recommendation to cover the face by any practical means, I think it was a big mistake. And I actually understand, I understand, like I said, the reason, trying to avoid hoarding, but of the masks, right? So trying to avoid that people hoard these products that are extremely important for the medical personnel. I don't believe actually that the solution should be these type of near lies, I would say, because this the statement made regarding whether people should wear masks or not were misleading at best and lies actually at worst. Because again, it is practically a lie to say that it makes no difference. Whether it makes a small difference, a big difference, that's again, let's say it's up to debate, although I have a strong opinion that actually it makes a big difference if it's implemented at the population level, if enough people actually get into this habit. But it was not a good idea actually to have these recommendations in such a misleading manner, because like I said, I believe they're wrong, but also they increase the distrust, I think, of the population in some institutions of authority that need to be like that. They rely on trust in order to have an effect. And I should say that we have good examples from some countries like Japan that have where people actually have this habit of wearing masks in the flu season, in the cold season, in the public transportation, because and in general in crowded places. Now, of course, I have no proof that that's the main reason why the epidemic didn't spread as much as in other countries. I have a personal feeling that it does make a difference. I mean, it contributed quite a lot, this habit of covering the face. And again, it doesn't have to be all the time, especially since United States has huge areas of very low density of the population. So I mean, if one walks in a park alone, let's say, there's not much of a point to do that. But again, just by using some common sense, if the person goes into a higher density area or in an area where lots of people come in and out, like a big grocery store, I don't think would have been a bad idea to actually strongly recommend people to wear masks in such situations. And I think it was a mistake that didn't happen. Although watching recent news conferences, I think they might change that a little bit. And the cynical in me says that they might change this recommendation once they actually are sure that the hospitals have enough supply ready. But again, I think it could have been approached differently, so that people have the correct recommendation while still finding a way to avoid hoarding and depriving the hospitals from the necessary equipment, because this indeed is important. I mean, the medical facilities are the most important. They are first in the line when they should have access to this protective equipment. But again, and let me end with this: even a scarf, again, if most people actually would do that in crowded places, might actually make a difference. It doesn't have to be a high-grade medical mask. So that's all I have on this topic. I'll see you next time.